3.5 properties of circles. Okay, so in the last couple of units, we've had what seems a little bit random lesson at the end of the unit dealing with circles. Same is true in this unit. So we're dealing with properties of circles, and we're verifying properties and testing properties and all that kind of stuff. And the first thing we're doing is taking a definition. Okay, we're learning about a chord. Does anyone know what a chord is? Like if you had this parabola shape, would you know how to draw a chord? Or a circle? Okay, that's okay. A chord is a line segment. A chord is a line segment joining, or that joins, joining 2 points on a curve. It's a line segment. It joins 2 points on a curve, which means it looks like, potentially, you can draw many different. It's a line segment, so it's a straight line with 2 endpoints, and it joins 2 points that are on the curve. So point A and point B are on the circle, and the line that joins them is called a chord. You can see how it cuts the circle into 2 parts. We're going to learn about chords. There's a name for actually a really special chord inside a circle? A diameter. Okay, diameter is a chord, and it has special properties that we'll learn about as well. But here we go. An investigation. Investigation 1 says, draw a circle in the space provided. Mark 2 points on the circle. Label them A and B. Investigation 1. Draw a circle. 2 points. Call them A and B. Mark step 3. Join these points to form a chord. Step 4. Draw the right bisector of this chord. For that, we're going to need a ruler. So I'm going to determine the length of my chord, my line segment AB. I'm going to call it 3.6, which means I get to draw a dot at 1.8 centimeters, which is right there. And I'm going to do my best from there to draw the right bisector. Now, it doesn't have to be, the best right bisector you've ever drawn. But one way to do it is just to use those lines that are already on your ruler at each centimeter marking and line it up with your chord. And then you should be able to get a pretty decent right bisector. How do I show that it's a right bisector? Well, it splits my chord into 2 equal pieces, and it meets it at a right angle. I need to put those markings to demonstrate what I have actually done. Yes, this problem will come up again. Verse 5. What special property does this right bisector have? What is interesting about this right bisector? What does it do? Where does it go? Ah, it splits the circle in half. Okay, let's write that. The right bisector of the chord splits the circle into 2 equal parts. Okay, if that's true, well, I'll give you a second. The right bisector of the chord splits the circle into 2 equal parts. What does that mean the right bisector does? Where does it go through? It goes right through the center of the circle. The right bisector of the chord Mr. V, couldn't you have even written these notes differently so we didn't have to write that part of the sentence twice? Yes, but I didn't. The right bisector of the chord passes through the center of the circle. Well, that's helpful. Hey, I have a question. Can I use this picture to find the exact center of the circle?
No.
No. I just get like every point along that line, along the diameter. A diameter. There's an infinite number of diameters to a circle. Could I add something else to the picture in order to find the center of the circle?
Yeah.
What could I do?
Put it on a Cartesian grid.
Yeah.
No.
I mean, you could.
Yeah.
Add endpoints to either side.
Of like here and here?
Yeah.
How would that help?
Find the midpoint.
Then find the midpoint of that? Yeah, again, I don't actually know this point, and I don't actually know this point.
So if we put it on the Cartesian grid.
And I don't know this point, and I don't know this point. Could I draw anything else to identify the exact center of the circle? It's a brain game. I'll give you a second to think about it. Okay, this will come up again, so make sure you pay attention. All I need to do is draw a second chord, find the right bisector of that chord, and if this right bisector travels through the middle of the circle, the center of the circle, and this one travels through the center of the circle, then the center of the circle must be where they intersect. The point of intersection must be the center of the circle. It's the only point that they will have in common. They will both go through the center of the circle. So, no math, no coordinate geometry whatsoever, just a picture with some markings on it, and you can find the center of any circle. Yes?
Yep.
Alright, looking down at investigation 2 then. Investigation 2. Choose one spot on this paper, but do not mark it. Choose one spot on the paper, down below, but do not mark it. Did you get it?
Yeah.
Okay, good. Don't mark it. Now, choose 3 other points that are equidistant from the spot you chose. And this can be just kind of relatively equidistant. So you could, if I'm picking this spot, I might pick one there, there, and doesn't really matter where you do it, but yeah. Okay? Label them P, Q, R. And trade a booklet with someone in the class. Make sure you do not have your own booklet.
Wait.
Wonder if I'm gonna trick.
Oh, I
Yeah.
thought it was on a circle. Oh,
Yeah.
Next step. Find the center of the circle that goes through P, Q, and R. Does it say to draw the circle?
No.
No, it does not. It says find the center of the circle. Do not draw the circle. Find the center of the circle that will go through. So the circle will go through P, Q, and R. And you need to find the center of it accurately. And you already know how. My friends, does your diagram look something like this?
Yeah.
You drew 2 chords.
it's on.
I could have drawn the chord PR as well. And if I did, and I drew the right bisector, it also would go through this point. But you should have 2 chords and 2 right bisectors, a right bisector for each of those chords. And where that goes through is
The
the center of the circle. Why? Because the right bisector of this chord goes through the center of the circle, and the right bisector of chord RQ goes through the center of the circle. Go ahead and grab your compass. Okay? Put the point on the center of the circle. Stretch the pencil side to one of your points. to one of your points, and then draw your circle. And see if you did a good job.
Wow.
Oh,
Okay, ladies and gentlemen, let's head on to example 1. Example 1 is, this time we're not just investigating what the right bisector of a chord does, we're actually going to verify it using coordinate geometry. So, by the way, this unit, 5 lessons. Lesson number 1, investigate properties of triangles. Lesson number 2, verify properties of triangles. Lesson number 3, investigate properties of quadrilaterals. Lesson number 4, verify properties of quadrilaterals. Lesson number 5, investigate properties of a circle, and then also verify properties of a circle using coordinate geometry. Okay, it says, verify that the center of this circle lies on the right bisector of chord AB. Well, let's go ahead and draw the right bisector of chord AB first. Maybe let's just draw chord AB. We'll leave it at that for now.
With a ruler.
There's chord AB. All right, well, what do you know about the right bisector of a chord, and how could I verify that it goes through the center of the circle? How can I do that?
You make it a right.
I need to make sure that it hits AB at a right angle. So what am I talking about there?
In a bisector. So
Perpendicular. So what am I verifying? What am I?
slopes.
Slopes. Okay. Needs to have up recip slope. Okay, there's one thing we're looking at. And what else are we looking at? How else could I draw this thing? I need to be able to draw this right bisector. It needs to go through the midpoint of AB. Needs to go through the midpoint of AB. Alright, so I'm looking at doing two things. First, I'm looking for the slope of AB. So slope of AB, that looks like this, MAB. What's my slope formula?
Y2 minus Y1 over X2 minus X1.
Okay, if you don't know that yet, you absolutely need to know that. So I'm just going to pick maybe B to be X2, Y2, and A to be X1, Y1. So in the numerator, I have 2, take away negative 4. 2, take away negative 4. In the denominator, I have 4, take away 2. 4, take away 2. Reduce. 2, take away negative 4 is 6. In the denominator, 4 take away 2 is
2.
Slope is
3.
So I note I have the slope of AB is 3. Okay, I'm going to move on. I'm just going to find more stuff about AB first. I'm going to find the midpoint of AB. It's going to have coordinates x, y. All this mathy-mathness, can you understand this? Capital M for midpoint.
Yes.
AB tells me I'm finding the midpoint of AB. Okay, I could do a little note for us as well to help us out. Midpoint of AB. And who knows our midpoint? Formula.
X2 plus X1 over 2 and Y2 plus Y1.
Thank you. And this is a bit easier to plug it in. I'm going to plug in the x value from A, that's 2, plus the x value from B, that's 4 over 2. Y, that's going to be 2, I guess I should do it the same way that I was doing it. Negative 4 plus 2 over 2. Close it off. Simplify. 2 plus 4?
x
divided by 2.
3,
Negative 4 plus 2.
2,
Eh.
or negative 2.
Negative 2. Negative 2 divided by 2.
Negative 1.
Negative 1. Alright, so there's my midpoint. Midpoint at 3, negative 1. Okay, so the right bisector, coming back to our slope thing here, the right bisector is perpendicular to AB. So our new slope, the slope of Mr. Right Bisector,
RB.
sure, lowercase rb, is going to be the opposite reciprocal. Go ahead and jot down the opposite reciprocal of a slope of 3. Don't call it out. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, what's the opposite reciprocal of 3?
Negative 3 over 1.
Eh.
1 over 3.
Negative
I wrote
1/3.
it down correctly, so it's fine.
Good, so that gives us the slope. Oh, okay, I have a slope. And by the way, I'm trying to find out if this thing goes through the center of the circle or where it goes through the center of the circle. And I didn't tell you anything about this circle, but this circle is actually drawn,
Circling.
and it's right at the origin is the center of the circle. So
0, 0.
I was hiding information from you as we worked through this, but the center of the circle is 0, 0. So what I need to determine is whether or not my right bisector goes through 0, 0. Well, do we have a way of verifying whether or not a point is on a line?
Yes.
It has to satisfy the equation, which means we actually did all this work because we need an equation of the right bisector. Okay? So here we go in our last step. Not our last step, but get equation for right bisector. Okay, so I have the slope, and I have a point that it goes through. So I use point slope form. Write down point slope form because you have it memorized. Is that the only way to get the equation of the line?
Probably not.
No. You could also just use y equals mx plus b, sub in the point m, solve for b. B will be 0. Anyway. Okay, here we go. Plug in what we know. We've got y minus negative 1, because that's the y coordinate of the point that it goes through. We've got a slope of negative 1/3, and then we've got x minus 3. That's nice of them to give us 3's to work with.
Thank you.
So here we have, on the left, we have y plus 1. And on the right, we have negative 1/3 x. Oh boy, this is so hard. I have 1/3, and I have 3 of them.
1.
And I have a negative times a negative.
1.
Positive 1, okay? Plus 1. How do I get rid of this 1 on the left-hand side? Subtract 1 from both sides.
Y equals 1/3 x.
Just y equals negative 1/3 x. Well, what do I know about the y-intercept? The y-intercept is 0. And what's the y-coordinate of the point?
0, 0.
Okay. So the y-intercept occurs where x is 0, and we're told that the point is at where x is 0, y is 0, and we're told that we're going through where y is 0, so we must be going through where x is 0, y is 0, which means we're going through 0, 0, which means we're going through the center of the circle. Does that kind of make sense? A little bit off and on? Okay. So the equation of the right bisector is y equals negative 1/3 x. And if we wanted to test this algebraically, what would we have to do again? Does it satisfy?
Yes.
Does 0, 0 satisfy the equation? Left side, y. Right side, negative 1/3 x. Left side, 0. Right side, negative 1/3 times 0. 0. Left side. Is it true that 0 equals 0?
Yes.
Therefore, my left side equals my right side? Okay. Great work, folks. Short and sweet.
Time to work on stuff.
Time to work on stuff. Okay?
Yes, sir.
Yeah. Hold on, let me just write the practice problems here. Practice problems come from the worksheet that you have, worksheet 3.5, and you can take on numbers 1, 3AB, 5, 6B, 7, and 8. Enjoy. Okay, recapping that example right from the start, I didn't give you your blanks. It says verify the center of the circle lies on the right bisector of the chord AB. The center, the point,
Yeah, good point.
the point 0, 0 lies on the right bisector only if the coordinates 0, 0 satisfy the equation of the right bisector. So the point 0, 0 lies on the right bisector only if the coordinates 0, 0 satisfy the equation of the right bisector. In order to develop an equation for the right bisector, we need its
Slope.
and
Midpoint.
Midpoint.
yeah, and another point on the line, or a point on the line. The slope and a point on the line. This point will be the, where did we get that point M from? What is that point M? It's the midpoint. This point will be the midpoint M of AB. We can't use 0, 0 because that's what we're trying to verify. Yes?
Yes.
Should have started with that information. Okay, carry on.